Hey there, calculus fans. Just trying to fill in a few holes here. I got quite a few questions in office hours today about the fundamental theorem of calculus part 1. If you ever need to review something like this, you could go back to that lecture from earlier in the term. Right now it's the day before the final, so we do need to remember a few things. But let me just recap. This was the foundational idea that led to the broader fundamental theorem of calculus, which said the derivative of an integral is f of x in this sense. And then we played around with different scenarios. If this was 5 and this was x squared and this was the square root of t plus sine of t or something, dt. We talked about what would happen if you took the derivative of that and how it's just using the same rule as above, but you also have to use the chain rule. People usually forget this because we don't use it that often. If there's also a variable in the bottom, if this is 5x, you do the same thing we just did, and then you do minus, and then you do the same thing with 5x. 5x plus sine. We did a lot of this earlier in the term, and at the time people understood it, but now it's been too long and we've forgotten. Okay, so when these questions pop up on old finals, people just forget. So it says here you have some sort of function. It doesn't even matter if the picture's accurate. You have something they're calling t and something they're calling 2t, and it's talking about this area. This area then is the integral from t to 2t of the square root of 1 minus x to the third. So now let's read the rest. Find the value of t at which a of t is maximum. So they're mixing in a little bit of pre-calculus. A of t is a new function. I have no idea what it looks like, but here's 0 and here's a half. You should remember that it doesn't matter what the graph looks like, the maximum is either going to be at 0 or at a half or at a critical point somewhere in the middle. And a of 0 is 0. And a of a half is going to be the integral from a half to 1 of this thing, which I have no idea what that is. Is there a reason we should know what that is? Half to 1. Then the only other question, so right now I don't know what the value is there. The only other question is if there's a critical point somewhere in the middle. How would we find such a thing? We would take the derivative and set it equal to 0, and that's what this question's about. Let's take the derivative. The derivative is the square root. Here's where this comes into play. So when this suddenly appears in a question, people kind of just forget about it altogether. 1 minus t cubed times 1. So that's this thing I was just talking about. So I think probably students had trouble with not because of that, but maybe because of the algebra. So if you're trying to solve 2 times the square root of 1 minus, let's simplify this as we go, minus the square root of 1 minus t cubed equals 0. Do you know how to solve that? Well, we would really like to isolate the square roots so that we can get rid of them, and that's fairly easy to do. And then we'll square both sides, so we're going to get 4 times 1 minus 8t cubed. Sorry that I'm running into this other work. And I can't even remember ever doing this problem before, so, correct me if I'm wrong. This is going to be 1 minus t cubed. Oh, and that's actually not too bad to solve. Let's expand. 4 minus 32t cubed is equal to 1 minus t cubed. Let's move this over and move that over. So 3 is equal to 31t cubed. So t is the cube root of 3 over 31. Find the value of t at which you have a maximum. Is that indeed a maximum? Well, we could think about the derivative. Is it a positive before and negative after? Or is there another way I could think about it? The second derivative? Oh, justify your answer, I see. So it does want me to do a little more. So if I had to do this, I'm trying to think of what would be the best way. I guess one thing is, I know when I plug it in, it's going to be positive. Can I convince myself of that? Or is it going to be negative? You could, of course, use a calculator. We know that it's 0 at 0. The value at 1/2 is positive because that integral is positive. Because all the numbers are positive. So it's somewhere here. So the question remains, does it look like this or does it look like this? So how could you figure out such a thing? I think this integral is always positive for these values. So if it's always positive, it's going to have to be like this and have to be a maximum. So it's got to be at that t value. So, but you could justify by other means. You could plug in a number smaller than that and larger than that into the derivative and see if it's positive before and negative after. Let's look at spring 2024. Make sure I'm not doing something silly. Let's see. Old final. Come on. Come on. Final exam archive's running slow. Everybody's on there. We said spring 2014. Ta-da. And let's take a look. Oh, I was going to look at the answers. Spring 2014 answers. Yep. 3 over 30. Cube root of 3 over 31. Okay. But the main point was the derivative piece. There's this question. I remember students really didn't like this question because it says, here's this function. It's a parametric question, but it says you have this function, whatever it looks like, maybe like this. I'll just pretend this is not accurate at all. Why? It's cosine. Why wouldn't I start with a high? Maybe it looks something like this. Okay. It's beside the point. You have a point over here and a point over here, and this is moving this way, and this is moving this way, and we're talking about this area. So what it's saying is you're doing the integral from some point to some other point of this function, 6 plus cosine of x dx. And then you're going to find the derivative of that thing. So that should make you think the fundamental theorem of calculus part 1, but it's got this piece that says these two things are changing. And here's what it says. At a given moment, you're at pi and negative pi, and you're traveling this way at alpha units per minute, and you're traveling this way at beta. Now, if those are constant values, then this point would be pi plus alpha t comma 0, and this point would be negative pi minus, well, it's moving to the right, beta. This is beta. I apologize. Just got to read carefully there. So this is alpha, and this is beta, comma 0. This is similar to the last one, but the last one, the formulas were a little simpler. The formulas were t and 2t. Now the formulas are pi plus alpha of t. Did I write alpha again? What is wrong with me? It's been a long day. This is beta. It's like I erased and wrote the same thing I'd already written. Apologies. Anyways, this is pi plus beta t. This is negative alpha minus alpha t. So the rest of the question is just asking you to take the derivative and figure out what's happening at that instant. The truth is, even if it isn't constant, if they tell you that the value is pi and the rate at that moment, they're telling you how to do this. So if we took the derivative, it's going to be the square root of 6 plus cosine of pi plus beta t times beta minus the square root of 6 plus cosine of negative pi minus alpha t times negative alpha. And then it wants to know at that instant when it was at that point, which would be at t equals 0, what the value is. And that's going to be the square root of 6 plus cosine of pi times beta minus the square root of 6 plus cosine of negative pi times negative alpha. And so this is the square root of 5, and this is the square root of 5. So you get the square root of 5 times beta minus negative alpha. So you get alpha plus beta times the square root of 5. No, and I remember that question being challenging for students. This is winter 2015. Let's see how we did. Winter 2015, answer, success. That's all I'll say about that.